Solar storms. In 1859, an amateur astronomer named Richard Carrington climbed the stair to his private observatory near London. He adjusted his telescope and projected an image of the sun onto a screen. He was looking at sunspots, areas of the sun that appear darker because they are slightly cooler than the surrounding areas. Suddenly, two patches of white light appear around one sunspot. Before dawn the next day, spectacular displays of red, green, and purple light, known as auroras, lit up the sky as far south as Panama in Central America. In the eastern United States, people were able to read newspapers outside in the middle of the night. Further west in the Rocky Mountains, the light confused campers enough to get up and start cooking breakfast. Some people even thought that cities had caught fire. What Carrington had observed was a solar superstorm, a massive eruption on the surface of the sun sends billions of tons of electrical and magnetic matter hurtling through space. It even caused damage here on Earth. When the matter collided with our planet's magnetic field, it caused electrical currents to surge through telegraph lines, disrupting communications. No solar superstorm as powerful as 1899-59 event had occurred since. That's why scientists find it difficult to calculate the impact a similar storm might have on today's more wired world. A hint came in 1989 when a solar storm, a third less powerful than the Carrington event, caused 6 million people in Canada to lose power. A Carrington-class storm could leave millions without light, drinking water, sewage treatment, heating, air conditioning, fuel, and telephone service for months. Few objects seem as familiar as the sun. There it is, up in the sky every sunny day. Yet few objects are so strange. Look through the solar telescope, then the sun is transformed. Streams of the lights, the side of the planet rise into black space, only to come back down hours or days later, as if controlled by some unseen force. Neither solid, liquid, or gas, the sun is made up of plasma, the four states of matter. Scientists are learning more about the sun and how solar storms form. The sun is packed with magnetic fields, some emerging on the surface as sunspots. They help to power the solar screen, sending a constant stream of particles out into the solar system. These fields can also become entangled with plasma, forming gigantic loops that are illuminated by the hot, glowing plasma. When loops cross, they cause the enormous plasma eruptions known as solar flare. Such flares release intense energy into space.